So let's have a closer look of the OR operator. The OR operator is denoted by a pipe symbol, and the OR operator returns true if any of the one of the logical input is true or evaluates to true. If all of them are false, then it returns false. Let's take a case and first understand the OR operator concept. Suppose I want to have a particular food in a particular joint. So I'm saying either I can have this or this or this, which means if I have one of the three, I will have food, which means that it will be my food will be served if any of the three options are available over there. So in that case, I'm applying OR operator. If none of them are present, in that case, I will have no food, which means if both the variables are 0, in that case, I will have an output 0. Otherwise, either or. So similarly, here you can see A and B. If A is present, B is present, in that case, you will have food. If A is present but B is not present, then also you can have your food. And in the third row, you can see if A is not present but B is present, then also you will have your food. But in the third last case, if neither A is present nor B is present, in that case you cannot have your food. So there we are trying to have a kind of 0. Let's understand how we can put these operators element-wise. So element-wise logical operator, or you have seen the example that it returns true if either of the operand is true. It will return true. As you can see over here, that in this case, if your list is true, 0.1 and list 2 is 0, 4 plus 3i, in that case, we will apply list 1, pipe symbol, list 2, and we are doing element by element logical OR operation, and we see the result true. So you can see over here that true and 0 will return true because either of the two values is true. True is true and 0 is false, but the final result is true. Likewise, 0.1 is true and 4 plus 3i is also true. So we have the output true. Next, we have the NOT operator. Now you will ask, what is NOT operator? NOT is a very simple unary operator because it acts only on one variable, and we call it unary. So it is a unary operator that negates the status of the element of the operand. It will negate the status. For example, take the data of input once again. Here, list 1 is equal to C function, within brackets we pass 0, false. So we pass 0, false, which means both the values in my vector are 0 and 0. So now if I write print not list 1, which means I'm reversing the values of my list, which is false. So the output becomes true, true. Likewise, we have logical AND operator. AND operator is an operator. It returns true if both the first elements of the operands are true. So it will return a true if both the first elements of the particular list are true, only then it will return true. You can see over here that logical AND operator is denoted by double ampersand, and you can see that list 1 is having a vector true, 0, 1, 0.1, and list 2 is having a vector 0, 4 plus 3i. And now I print list 1 and list 2. So you can see the output false. Why the output is false? The output is false because the logical AND operator will return true if both the first elements, I'm saying both the first elements of the operands are true. But in this case, both the first elements are not true because the first element of list 1 is true, but the first element of list 2 is false. Likewise, we have the logical OR operator or the double pipe sign, and it compares the first element of both the list the way the logical AND operator was comparing. So here it returns true if either of the first element of the operand is true. So here again the input is same. For the list 1, the first element is true. For list 2, the first element is 0, which is false. But If we take the case of only of the first elements of the operands, we will see that there are true exists. And so if we write print list 1 logical OR operator list 2, it will return true. Now, let's have our program to illustrate the use of logical operators and see what is happening and how the results are coming. Again, there is a piece of code which you have to understand. The first line is vector 1, which is equated to a vector created by the C function. Then the vector 2, which is again a vector of the values true, false. And now we are printing the results on the screen. So you can see over here, the first cat command is printing element-wise AND operator. You can see when we print element-wise AND operator, we use single ampersand symbol, which is vector 1 ampersand vector 2. So this will compare each and every value element by element for the entire vector. Likewise, if there is element-wise OR operator, in that case, vector 1 will be compared with vector 2 and the entire vector will be checked for each and every element by element. On the contrary, if I'm using logical AND, in that case, I'm doing vector 1 and vector 2 with double ampersand symbol, and only the first element of vector 1 and vector 2 will be compared. And if they both are true, only then the result would be true. And likewise, if it is logical OR, the first element of vector 1 will be compared to the first element of vector 2. And if they are any of the values is true, the final output would be true. Again, if I go for negation, in that case, what I'm doing, I am just reversing the Boolean values, the true and false of the entire vector to its opposite. Or I can say I'm complementing, we call it negation. I'm complementing the values. So you can see over here, vector 1 is what? Vector 1 is 0, 2. So there, if we convert that into the Boolean values, it becomes false and true. So you can see the negation is true and false. And that is how we are printing on the screen. If, else, if statement in R. So students, as we can see all the bulleted lines over here, you can see there is a command which is called as if command. There is a if command and within brackets there is a condition. Condition is what? It is a criteria. As we have seen, there are 6 relational conditions and we can apply a condition over here. Now let's say that if age is greater than equal to 18. If age is greater than equal to 18, I have to do something. If age is less than 18, I have to do something else. So basically what I'm doing, testing the condition. I'm testing the condition, and if the condition is true, I'm executing this block of condition if it is true. Whatever commands are right within the curly brackets, that is executed. Otherwise, whatever commands I write in the second set of curly brackets, that block is executed if the condition is false. Now, let's take example and understand the code. This is a code where there is a variable x which is equal to 5. You can see over here that there is a variable x and it is equated to 5. And now I'm checking the value is less than or greater than 10. So I'm checking with the help of if function. If function x is greater than 10, in that case I'm using a paste function and I'm printing on the screen x, that is the value, and is greater than 10 is printed as it is on the screen. So you can see if x is greater than 10, I'm printing x is greater than 10. Otherwise, I'm printing x is less than 10. So what I'm doing, I'm basically taking a variable x, comparing that with 10. If it is greater than 10, I'm printing one message, and if it is less than 10, I'm printing another message. Now, let's understand the concept of nested if. You must be thinking that nested if is something where we can nest one if inside another if. If there is if command and I can put another if inside that command, then I'm calling it nesting of ifs. That is, multiple conditions are stacked once inside the other. You can see over here, variable 1 is 6, variable 2 is 5, variable 3 is -4. So there are 3 variables, variable 1, 2 and 3. Now, if I have to checking if else letter. If variable 1 is greater than 10 or variable 2 is less than 5. So in that case, I'm doing what? I am checking 2 conditions. With the help of the pipe symbol or operator, I'm checking if variable 1 is greater than 10 or variable 2 is less than 5, which means two conditions are checked. Print condition 1. I'm saying this is my first condition. Otherwise, I come on the else part and again give one more if command. There I'm checking if variable 1 is less than 4, print condition 2. And otherwise, what I do, I check again if variable 2 is greater than 10, print condition false, otherwise condition 4. So that is how what I'm doing. I'm printing 1, 2, 3, 4, 4 conditions on the basis of multiple conditions. You can see here in this code snippet that this is an out and out case of nested if, where inside one if I have incorporated one more if. You can see that the first if is variable 1 greater than 10 or variable 2 less than 5. Otherwise, I check if variable 1 is less than 4, and otherwise if I check variable 2 is greater than 10, and that is how I'm making my conditions. The program might not sound very logical over here because we have just discussed the syntax, but the idea is that you have to understand that inside an if we can put one more if. Looping is repeated execution of certain commands again and again until a condition is satisfied. So basically, if you see the flowchart over here, that there is a particular last item reached. We are checking, is the last item reached? If yes, execute the statement. Again, go and check, is the last item reached? If it is yes, execute the statement, last item reached. If it is no, in that case, exit the loop. So if last item is reached, if it is true, execute the statement, and that is how we are trying to understand. So you can see over here that in this code, we have, first of all, we have the for command where is the reserved word for is there in the for loop, var in vector. So var is what? Var is a value, a variable in a vector list, in a vector. And if the variable, the value in the variable is present in the vector, the statement is executed. In the next line, you can see our program to demonstrate the use of loop. This is an actual code where you can see for I in 1:4, which means I am checking whether I is present in 1:4 or not. So what happens? My list is 1, 2, 3, 4, and I am checking I in 1, 2, 3, 4, and I print I to the power of 2, which means square of I. And you can see the output over here. The output is 1, 4, 9, and 16. So this is basically printing the square of all the numbers which are ranging between 1 to 4. So that is how we are printing the output on the screen. And we can see over here that this is, the program has become so compact. It is just a 2-line command now. There is a for command, and within the for I am putting var in the vector, var in vector, and var is my variable, vector is my list of numbers, and in the curly brackets, I'm writing the print command. So the program has become so small. Condition is inbuilt within the for, where I'm not putting any condition that if I is greater than 4, then stop. No such kind of programming. It is a very compact notation where with just one for command and within the brackets, the value in a range, I'm printing the result. Let's have a look of one more example and understand the concept better. Now, this is a R program to demonstrate the use of loop with a vector. Now here you can see that x is my vector, which is created with the help of C function, and here I have 8, 9, 11 and 45 as values. For I in x, so I am writing very clearly for I in x, x is my vector. So for I in x means whichever value is there in x, print I. So I am printing the value, whatever the first element of value of x that is stored in I, and that I is printed on the screen. So you can see that the entire vector is printed on the in the output box as seen clearly on the screen, and the entire vector is printed with just two commands. The first command is the for command and the second command is the print command. You will say that we have created a vector and that vector is also adding to a command. Definitely we have created a vector, so that is also a command. But sometimes it happens that we have created one vector and we are printing that at lot many places. So there basically the for loop command is just one line command where we are giving one print command. So that is why the notation has become very compact.